6.1. Now I think you've pretty much gotten a handle on how to work proportions. We'll do a couple of these. Let's take number 24. Okay, it says y, you could see it, it would say that. It says y over 20 equals 3 over 10. Now I know what some of you are doing. Some of you are automatically saying 20 divided by 2 is 10, or 10 times 2 is 20, so y is equal to 6. That's okay. The only problem with that is if you're not learning how to work the problems when it's not that easy, you'll have trouble with it. So let's talk about the way you're supposed to do it algebraically. You want to do cross products, which is 10y equals 60. Divide both sides by 10, and we get y equals 6. Okay, so that's how you're working these proportions. Now, the biggest problem I'm seeing that people are having is they forget what to do with a geometric mean. Now, we know what the means are. These are the means, and these are the extremes. And we remember that those are called the extremes because normally the highest number is down here and the lowest number is up here. That's not always true, but generally speaking, that's how people will write a proportion. A geometric mean is when the number on the bottom, the mean over here, is the same number as that one. For instance, if we were to do this on purpose, we could say, well, 4 is to 8 as 8 is to, okay, the 8's are the same. All right, the way to figure out what this last one would be is to say, well, 4 times 2 is 8, 8 times 2 is 16. So we say that 8 is the geometric mean between 4 and 16. Okay, and the geometric mean is a geometric relationship. So looking on page 361 in section 6.1, we are being asked to find the geometric mean of the two numbers. So number 31 says to find the geometric mean between 2 and 18. Okay, well the way to do that would be to say, well, 2 belongs up here and 18 belongs down here. All right, x times x is x squared, and 2 times 18 is 36. Now, be careful with this x times x because you're going to want to say 2x, but that's not correct. This is x times x, which is x squared. Take the square root of each side and you get x is equal to 6. Now, this happens over and over for every one of these problems. We have 4 and 25, so we would have 4 and x or y or whatever, and x and 25. So we have x times x is x squared. 4 times 25 is 100. So take the square root of both sides and we get x equals 10. So the shortcut is to remember that to find a geometric mean, multiply a and b. So what they write is, on page On page 359 in the middle, it says the geometric mean of two positive numbers, a and b, is the positive number x that satisfies a over x equals x over b. So, x squared equals ab, and x is equal to the square root of ab. So a short way to do this, they've written in example number 6, x is equal to the square root of a times b. So the shortcut for this would be to say, well, this is a, and this is b, so x is equal to the square root of a times b, or x equals the square root of 36, because 2 times 18 is 36, or 6. Now another problem that people are having is being able to simplify these square roots. Square roots are also called radicals. So let's talk about how to simplify these, that way you can roll it back and listen to it over and over again. Let's find a few that are going to need to be simplified. Let's take number 35. It says to find the geometric mean of 2 and 25. Okay, following our rule, you're going to say x is equal to the square root of 2 times 25, which is 50. There is no perfect square root of 50. Now you remember that there are certain perfect squares. Perfect squares are 2 times 2, which is 4, 3 times 3, which is 9, 4 times 4, which is 16, 5 times 5, which is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64. Okay, so what you want to ask yourself is, could I factor this, find numbers that can be multiplied together that include some of these perfect squares? So I look at 50 and I think of 50 cents. 50 cents is 2 quarters. A quarter is 25 cents. So we do have a perfect square here. So we're going to say 25 times 2. We've split it up into its factors. Since we can take the square root of 25, we're going to take out the square root of 25, which is 5. We can't take the square root of 2, so we're going to leave that as the square root of 2. And that is how you simplify a radical. All right, then number 36 says find the geometric mean of 6 and 20. Again, x is equal to the square root of a times b. A times b is 6 times 20, which is 120. Now, we're not going to recognize this one quite so easily, so we're going to have to use a different strategy to find the square roots that this can be broken down into. Okay, so in this one we're going to make a factor tree. If you remember doing that when you were doing regular arithmetic, probably before so much algebra, and you can just split this up into its factors. We have 2 and 60, and it's easy just to keep dividing by 2. 2 and 30, 2 and 15, 3 and 5. Now what you want to do is find pairs of factors that can be pulled out of here. Okay, we only have one pair. Now remember, when you take a square root like the square root of 4, it's the square root of 2 times 2. And it's equal to 2. So when you take out a pair of 2's, that's like part of the problem. Okay, so when you take out a pair of 2's, the pair inside the square root becomes 1 on the outside. All right, so we're looking at this and we have x is equal to 2 times 2 times 2 times 3 times 5. So we can take out a pair of 2's, but that's, so we would say 2, we're going to pull that 2 out from under the radical. 2 times the square root of 2 times 3 is 6, 6 times 5 is 30, and we're going to leave that. X is equal to 2 times the square root of 30. Now you may not need to do that factor tree. You may look at that and think, square root of 120, in your mind, you may say, well, that's the same thing as 4 times 30. So you will say 4 times 30, and then you'll pull the 4 out from under the radical by taking the actual square root of 4. So you're really doing this. Okay, and remember that if you have a radical that's multiplied, you can take each one separately. So the square root of 4 is 2 root 30. So that would be 2 root 30. Now you would want to stop and ask yourself, is there a perfect square in 30? Well, 30 is 6 times 5 or 3 times 10, but there are no square roots, no perfect squares in those. Okay, so that's how you work the geometric means.